So I'm now recording this session so that you can see, you can watch it again later if there are bits you missed, or if you've missed the lesson altogether and you've just logged in a bit late. Not to worry. Well, obviously, if you just logged in a bit late and you're watching this, then you know it's recorded because you're watching the recording. So I won't say any more about that. So these momentum questions, remember what I said before about how to go about answering questions in a way that is easy to understand and easy to follow. And I did say right at the beginning that when you first start doing this particular type of questions, you'll find that it's very, very easy. You'll sort of find it quite easy to do, but you'll think that well, the question's so easy, why am I doing this? Well, it's for questions like this. So we've got a railway engine. Oh, there goes my lights. Got a railway engine with a mass of 80,000 kilograms, traveling at 5.3 meters per second, collides with and becomes attached to a truck of a mass 20,000 kilograms, traveling at 1.8 meters per second in the opposite direction. My goodness, that looks awful. Got to calculate the speed of the truck and the engine immediately after the collision. It says they become attached, so they get stuck together. So what do I do? Well, I think the first thing we do is we look at what we're given. We are given, first of all, we're given the mass of the engine, and we're given the initial velocity of the engine. We're given the mass of the truck and the initial velocity of the truck. So if we put it over here, it makes a lot more sense. I'm just going to see if my desk lamp's working. I do apologise. Somebody's obviously disconnected all my lights and left me in the dark. There we go. Right, I've got a desk lamp. Thank goodness. Sorry about that. So the mass of the engine is 80,000 kilograms. The mass of the truck, bear with me, something's just gone very weird there. There we go. The mass of the velocity of the engine initially was 5.3 meters per second. The mass of the truck was 20,000 kilograms. And its velocity, now be careful, it says the opposite direction. So that's negative. That's going to be negative, isn't it? Minus 1.8. So I'm going to count that as minus 1.8 meters per second. Just makes life a lot easier if you make a list of what you're actually given. Now, we can think about what happens before. So before our collision, we know the momentum was the momentum of the engine, which is the mass, multiplied by the velocity, which is 5.3, plus the momentum of the truck, which was 20,000. Now, I've got to be careful, it's multiplied by minus 1.8. So if we do our sums, by my reckoning on my calculator, that came out as 388,000 kilograms meters per second. Okay, so that's the momentum before. So we know the momentum afterwards is going to be the same. We assume, unless the question tells us otherwise, we assume it's got no external forces. So that's going to be the momentum afterwards. So 388,000. So after the collision, 388,000 is going to be the mass. Now, if they stick together, it's going to be the combined mass. So it's the mass of the engine plus the mass of the truck, which very conveniently comes to 100,000, multiplied by V. We don't know what V is. So we just got to calculate it. So if we actually solve this, that's 388,000 divided by, well, 80,000 plus 20,000 is 100,000, is equal to 3.88 meters per second. Okay, and it's moving in the same direction as the railway engine was at the beginning because it's positive. So that is how you go about answering that question. Start with before, end with after. So that's a sort of very standard collision. The next question is actually an explosion question. It's a very common type of question. Almost every momentum question in exams that I've come across is usually involved something like this. So you've got an air rifle pellet. Air rifle fires pellets of mass of 0.5. Careful, grams. Got to be careful of those units. We've got to convert to kilograms at a velocity of 160 meters per second. If the air rifle has a mass of 0.8 kilograms, calculate the speed at which it recoils. So what they're saying is that we start off with a rifle and a bullet, which are stationary. So before, momentum before is just 0 because it's not moving. So afterwards, you fire the bullet and the rifle sort of fires backwards, sort of goes backwards. So the speed of recoil is going to be negative. The velocity of recoil should be negative. So after is going to be the momentum of the bullet. Now it's mass. Now 0.5 grams is 0.0005 kilograms multiplied by 160. Now you've got to do minus. It's going to have a negative velocity. So we're adding together the momentum of the air rifle, which is going to be mass of 0.8 times by v. Okay, because we're going to put that there instead of putting v as a minus there. Okay, so we're assuming it's going to be negative, so I'm actually putting the minus here so I get a positive number. It just balances out a little bit more easily. So all we're then doing is we're just doing a basic solution to an equation. Is 0. So we know that that is going to be 0.08 minus 0.8 v equals 0. Well, okay, I could say 0.8 v equals 0.08. Okay, divide both sides by 0.8. Gives you 0.1 meters per second. Okay, we've made that positive because I actually defined the negative direction here. Okay, so that is how you go about solving it. Think about what's going on before and afterwards of any conservation of momentum question. The next conservation of momentum question is about a railway engine again. It looks very, very similar. A railway engine of a mass of 40,000 kilograms traveling at 4.7 meters per second collides with a truck mass 10,000 traveling at 2 meters per second in the opposite direction. So that's negative. So after the collision, now both the engine and the truck are moving in the same direction, but they're not stuck together. So we have to think very carefully. So we work out, first of all, the before, because we can work out the total momentum before. Before the total momentum, we're just assuming the direction of the engine is going to be positive. It's mass 40,000 multiplied by the velocity 4.7 plus the momentum of this truck. So that's going to be 10,000 multiplied by minus 2 because it's moving in the opposite direction. Okay, so we calculate that and I think we get 168,000 kilograms meters per second. Okay, then we think about afterwards again. So the key is really with a collision question is to remember that the momentum is exactly the same. So it's 168,000. Now, because these are not stuck together, we have to treat their momentum as being separate. So it says the engine and truck are moving in the same direction. The engine is moving with the velocity of 2.1 meters per second. Now, notice it's 2.1 meters per second, positive, so it's going to be in the same direction. So we're going to assume that's the same. So it's 40,000 multiplied by 2.1 plus, because it's moving in the same direction, 10,000 times v. And we want to work out v. So again, what is this? This is just a simple solution to an equation. So if we subtract that from that, we end up with got to look at my notes here because I've got to cheat a little bit to look at my notes. 84,000 Okay, it's 84,000 is that minus that. So that's going to be 10,000 V. So 84,000 divided by 10,000 is V. So if we work that out, that's going to be 8.4 meters per second. Okay. So that would make sense. It's positive, so they are moving in the same direction. If that came out to be negative, then I'd know that either there was something wrong with the question or there's something wrong with my answer. So it'd be a good way to check. The other way to check is to ask yourself if it's reasonable. Well, it's the same order of magnitude of the other velocities. The other thing to remember is that the railway engine has a lot of momentum. It's got a very high mass. Its speed has quite drastically changed. So it's obviously imparted a lot of its momentum to the truck. So we'd expect the truck to be moving substantially faster than it was because it's got a lower mass. It was already moving at 2 meters per second. We'd expect it to be more than 2 meters per second afterwards, and quite a bit more because it's imparted a lot of momentum and the mass is low relative to the engine. So you can start looking at your answers and just ask yourself, is it reasonable? So that is roughly how you go about answering a fairly complex collision question. You can see that question looks like a nightmare, but if you just follow the technique, work out the total momentum before or an expression for the total momentum before, and work out the total momentum afterwards or an expression for the total momentum afterwards, and knowing that the two are equal, then you can, it's just a maths equation to solve. It's no more complicated than that. So if I do one last one, hopefully you've got yours in front of you and you've done reasonably well. No one sort of stop me and ask me any questions. So we've got a controlled explosion results in 2 pieces of shrapnel. Shrapnel is something that flies off when a bomb goes off. One piece of shrapnel has a mass of 0.5 kilograms, is moving with a velocity of 300 meters per second. Assuming that the second piece of shrapnel is moving in the opposite direction to the first with a velocity of 275 meters per second, what is the mass of the second piece of shrapnel? So again, this is momentum. So we start off by working out momentum before. The momentum before, well, it's a bomb. And initially, it hasn't exploded yet. So if it's not exploded yet, nothing's moving. So the momentum is 0. So we then say, well, the momentum is going to be the same afterwards. So let's get an expression for the momentum. So this one says, this part is 0.5 kilograms at 300 meters per second. Now this part is moving in the opposite direction. So I'm going to define that by showing it's got a negative momentum. So it's 275 times by the mass, whatever that is. And that's equal to 0 because the momentum before is the same as the momentum afterwards. So this is just yet another basic equation. 275 m is 150. Therefore, the mass is, well, that's 150 over 275, which is, well, it's 0.56 recurring. Okay, but we want to give maybe 2 significant figures. So I would say, sorry, 0.54, I do apologize, 0.54 reoccurring. So if we give it to 2 significant figures, it actually comes out to be 0.55 kilograms. Okay. Now, is that a reasonable number? Well, they're moving off in opposite directions. Their velocities their speeds are very similar in terms of magnitude. So their speeds are very similar in terms of magnitude. So you would expect their masses to be similar. So we started at 0.5. Well, it's not a million miles off, so that's the right sort of ballpark. Plus, by inspection, this second part is moving more slowly. If it has the same momentum as the first part of the other part of the bomb, then you're going to expect its mass to be larger, but only by a little bit. So 0.55 is a little bit larger than 0.5. So you can check it to see if it's actually right and see if it makes sense. Okay, so that's how you answer those 4 example questions. Any questions, anybody? I've got a few minutes left. Anybody got any questions?
No.
All okay?
Yes.
Yes.
Okay. Can I ask who SC is? There's someone
It's Sadie, sir.
Sorry? Oh,
Sadie.
it's said no. Okay, that's fine. As long as I know. Zoom user keeps trying to come in, but then keeps leaving again. I assume that they've got a bit of an unstable internet. So if you missed today's lesson, if you missed any of today's lesson, or you arrived a little bit late in today's lesson, obviously I've posted now up on YouTube, on my YouTube channel, and there's a link to it on Show My Homework for today's lesson. If you go on Show My Homework and you click on the YouTube link, it'll give you a video of the first part of the lesson. Obviously, I've been recording the second part of this lesson as well. So fairly shortly, I'll post that up on YouTube as well. And I'll put the link to that again in today's lesson. So if there are any bits you've missed, you've been trying to log in and out, the sound's been dropping out, anything's been wrong, you've got a recording. For those of you for whom English is not your first language, don't forget that on the YouTube recordings, you can also call up subtitles, which will automatically translate into your own language if they're available. Okay, so tomorrow's lesson is going to be practice. The routine at the moment for the last couple of weeks has been, we've had sort of 2 days of sort of learning and learning key points and doing some worked examples together. And then we've had, sort of Thursday's always been sort of the practice day. So Thursday's lesson, it's quite simple. I'll just quickly call up the, what's that there? The lesson that you've had today, obviously, has been this Zoom meeting. I've put part 1, oops, is it? Oh, sorry about that. I just realized I've not shared my screen, bear with me. Try again. Right, so in today's lesson, obviously, you've got the YouTube link to today's lesson. I will add on the link to this lesson on the bottom of there as well. So if you want to view anything again, so if your sound's been dropping out, I know a couple of you have complained that your sound's been dropping out. What we'll do tomorrow's lesson, if the system will let me show you, is tomorrow's lesson is going to be mostly practice work. So in tomorrow's lesson, there's a Seneca assignment to have a go at. You know, they're pretty quick. Do take them seriously. But do the Seneca assignment on momentum. I think it's quite important to do it. That should take you probably about 15, maybe 20 minutes if you take it very, very seriously. For the practice questions, I've given you some practice questions, and it's as a Word document for those of you who want to sort of type it up. But that's really going to be for your practice. I reckon that practice question will probably take you another sort of 20-30 minutes to go through that. The practice questions will take probably 20-30 minutes to have a go at. And then what we'll do is I will log into Zoom for you at 10:30, and at 10:30 we'll go over those practice questions and make sure we know how to answer them. They're basic practice questions on momentum. Just to let you know where we are in terms of the course, we're almost done now. So what we've really got to do, I think, is energy and motion, and then it's going to be mostly practice in the run up to the UFP exams. Okay, any questions?
No.
No.
Okay, right. Well, I will see you all tomorrow. Well, try again. I'll see you all tomorrow, and hopefully my lights will be working again then, and we'll sort of consolidate and finish off momentum to our satisfaction, and then we'll move on to energy and motion, which is pretty easy actually. I think it's easy anyway, and so I'll see you tomorrow.